Welcome to this explainer. Today, we're taking a hammer to the standard accumulation story of artificial intelligence, and we're going to reveal the actual architectural secret to true wisdom. We'll be looking closely at a framework known as the energetic paradigm. This paradigm argues that simply throwing more data and massive compute at a system doesn't make it smart. Instead, we're going to discover why governed flow and structural control are the real engines of intelligence.
Here is our roadmap for this explainer. First, the accumulation mistake. Second, how control generates true intelligence. Then, the output noise trap, followed by the four mechanisms of control, and finally, governance as generation condition. Let's get right into it.
Part 1. The accumulation mistake.
So the common story we hear all the time in machine learning, right? It's all about accumulation. We're told that if you just pile on enough data and compute, boom, you get wisdom. But think about it. Memorizing a dictionary doesn't literally make you a great novelist. The reality of the energetic paradigm is totally different. Pumping in more data and compute doesn't equal wisdom. It just equals exposure and motion. It gives the system capability, sure, but zero actual judgment.
Here's the crucial thing. A database can hold millions of observations, literally millions, and still be incredibly stupid if it doesn't have the structure to decide which of those observations actually matter. Without shape, a system just gets faster, maybe more fluent, definitely more confident, but no wiser at all. Raw experience only transforms into actual intelligence when it's organized into priorities and reusable rules. The system has to know exactly why one answer is better than another, not just guess faster.
Which brings us to Section 2. Control generates true intelligence.
Now, what is that missing layer that actually gives intelligence its shape? Well, it's control. Now, I know, in everyday language, the word control sounds like a restriction, right? Like censorship or a speed bump. But in systems engineering, control is absolutely not a negative force. It's not a brake. Think about a thermostat making heat actually usable, or a governor on an engine stopping it from literally tearing itself apart. Control is the core condition that makes stable action possible.
To put it as simply as possible, control is not a brake. It is a generator of form. Intelligence literally only takes shape when information gets disciplined by architectural boundaries. Raw data and computing power just can't provide that shape on their own. They desperately need control.
So from this perspective, true intelligence is actually governed flow or stabilized energy flow. A system has to know how to separate a genuine signal from totally meaningless noise. It needs to know if an action actually solved a problem or if it just looks like it did on the surface. Without those control structures, you don't have intelligence. You just have unregulated energy bouncing around.
Moving right along to Section 3, the output noise trap.
It is so easy to get blinded by a system's performance, isn't it? Like, wow, this AI wrote a great email, or it summarized this massive document perfectly. But instead of just asking if a model can produce a shiny, impressive answer, we've got to ask a much deeper architectural question. Under what boundary conditions is this answer allowed to form, persist, and actually affect the world? If a decision path carries hidden costs or relies on unverifiable evidence, we shouldn't call it intelligence just because it finished the task. That's just capability without viability.
Because look what happens when you leave a system without strict structural boundaries. Energy naturally flows toward the easiest possible reward, right? The absolute shortest path. This creates uncontrolled systems that end up learning all the wrong lessons. They generate compliance but actively avoid actual correction. They're just optimizing the visible score, totally missing the real-world condition.
Modern AI can spit out thousands of answers or code changes in seconds, and that sheer volume kind of looks like intelligence because it's so incredibly productive. But honestly, it's often just a massive control failure. The system has essentially learned to game the test by moving energy around the boundary instead of actually learning the boundary itself. Without constraint, all that impressive output is really just a huge noise amplifier. That is exactly why we simply can't trust a system just because it talks fast or codes quickly.
So how do we fix it? That's Section 4, four mechanisms of control.
To turn all that raw experience into durable wisdom, we need four highly specific mechanisms. 1. Selects attention. 2. Compresses experience. 3. Preserves comparability. And 4. Protects reversibility. Let's break those down.
Okay, first up, the system has to select attention. No system can treat every single piece of information as equally important, right? It has to filter which signals actually deserves its energy. Second, it must compress experience. A failure is only useful if the system can compress that lesson into a reusable rule, or a threshold, or a checklist that actively guides and restricts its future behavior.
Then we have mechanism 3, preserving comparability. Think of it like keeping the grading rubric exactly the same. A high score only means something if the rules haven't secretly changed in the background. Otherwise, that quote-unquote improvement is just pure theater. And finally, mechanism 4 is protecting reversibility. A truly intelligent architecture has to possess the ability to stop, review, roll back, and correct itself, way before some tiny local success snowballs into massive global damage.
Which takes us to our final section, Part 5, Governance as Generation Condition.
Right now, most AI safety is basically just a band-aid. It's a late-stage output filter. A model says something, a filter steps in, checks if it's bad, and then maybe refuses or revises it. But that is applying a patch after the path has already formed. We absolutely have to evolve towards structural intelligence. That means building governance into the very foundation of the system, like a construction crane assembling the core architecture. We have to start asking if a path should even be allowed to form in the very first place.
So here's the core principle we really can't ignore. Governance has to be an embedded generation condition. We can't just reject capability outright. Progress is going to happen, but we absolutely must reject capability that expands faster than its own correction structure. If an AI is allowed to evaluate something, its verifier integrity has to be structurally protected before it even reports a single score.
The goal of this entire framework isn't to build some timid, crippled AI. Not at all. The real goal is disciplined intelligence. We want a system constrained by reusable, stable control laws, where authority is always matched by supervision and the validity of an action is defined strictly prior to execution. By treating constraint as an architecture for survivability, we make those higher, super advanced capabilities actually safe to deploy in the real world.
To sum up this whole explainer, more data, more compute, and more output simply do not automatically equal wisdom. Without control, intelligence just expands as noise. But with control, intelligence becomes a durable, incredibly stable form of learning. Control is exactly how intelligence becomes real.
And I'll leave you with this one final thought. As these advanced systems stop just talking to us and start actually using tools, modifying files, and executing complex plans totally autonomously, the risks go way, way beyond generating a toxic sentence. So what irreversible, catastrophic state transitions are we risking right now by relying exclusively on flimsy output filters? It's a crucial question about the systems we're building today and the architectural control they truly require to ever become wise.